Okay, so in the next 20 minutes, I want to talk about the field level communications initiative. I want to give you some background information, talk about the mission and the goals, and I will also a little bit explain the technical approach that we take to make OPC UA fit to the field level. I want to start with that famous press conference that took place November 2018 at the big automation show in Germany. And you have some impressions here from the press conference. There was a huge interest. And the main reason for this huge interest was that on the one hand side, the OPC Foundation announced the extension of OPC UA to cover also the field level. So this was important with regard to the further strategy of the OPC Foundation. But what was at the same time an extremely important message in connection to that was the big support from all the major automation suppliers to back this initiative. And you see here in the middle at the bottom the photo that also made it to a lot of magazines and newsletters. Stefan, our president, with the representatives of Rockwell Automation, Siemens and Mitsubishi, as they stand for one of the largest automation suppliers in the market and also covering the different regions in the world. Now, the FLC initiative today has a steering committee which is responsible for the overall project that consists of 26 member companies. And you see here the logos of the 26, which is a good mixture of automation suppliers and technology providers. I want to mention that these companies bring in a significant budget to make this initiative a success. And in addition, they bring in their experience and manpower to support the different working groups we have in order to develop the technical solution. Now, an important question is certainly what are the additional use cases the FLC initiative contributes to the existing ecosystem of OPC UA. You see here the more traditional areas of application with numbers 1 to 4. Now FLC is concentrating on the two use cases with the numbers 5 and 6. Number 5, the controller-to-controller interoperability. That means the connection between controllers of different vendors that are, let's say, integrated in different machines, in skids, in factory automation, as well as in process automation. And then number 6 extends the use case to also cover the field level itself. That means the connection from controllers to the different field devices, for example, servo drives, remote IOs, camera systems, safety devices, and whatever you need for your specific applications. What is important to mention is that we are creating a technical solution which is future-proof. That means we can easily adapt to other upcoming trends and technologies. And I want to just mention here as one of the example, wireless integration 5G, which is part of our technical approach to also allow the transmission of all that information out of devices, out of controllers over 5G technology. The overall vision of the FLC initiative is to aim for an open, unified, standards-based IoT communication solution. So this is exactly the same as the overall vision of the OPC Foundation. But what is new is now that we are addressing all the requirements for industrial automation, including the connectivity between all the different devices, controllers, and then also fully scale up to edge computing, cloud computing, so have full scalability across all the different levels and across all the different device types and software applications. We are specifically looking at different stakeholders that are, let's say, using such a technology for their different needs. So I put together a few examples to give you some insights what concrete requirements we are looking at. First example is on a machine skid builder who is desiring to have exactly one vendor-independent communication standard, which is capable and usable for all different requirements of this application. And this includes certainly all the requirements out of motion, safety, remote IOs, etc. And in addition, certainly the desire is that in case the network is also used for transmitting additional traffic, for example, video streams, that this additional traffic is not impacting machine performance or machine availability. Another use case is when we look at the requirements of a plant owner. The plant owner has certainly a high interest to be able to easily and economically integrate and connect machines or machine modules from different suppliers. And last but not least, I have one example of a data scientist. This is probably the most important use case if you look at Industry 4.0 and the Industrial Internet of Things, because the data scientist certainly is requiring access to all the process and production related information that he needs in order to, for example, identify opportunities for optimization. And certainly this data scientist wants to configure the information that is brought up to his application by himself without the need for getting additional support from a specific automation supplier. For discussing the different requirements and to, let's say, set up the technical concept, we are using a more abstract interaction model. This is what you see on this slide. So in scope of FLC are the interactions between controllers, from controllers to devices, including also the interaction between devices themselves. What is then important, and you have just seen this with the data scientist, that we certainly look very closely how to bring up the modeled information up to the compute functions. Compute in the context of our discussion stands for a gateway solution, any software applications, even including cloud. What is highlighted in green is that compute to compute itself is not in scope of FLC, but this is already covered by OPC UA as we have it today. But we certainly contribute also to this interaction because we bring up all the information from the controllers and from the devices, and then this is certainly important to do that compute to compute use case as well. Explaining a little bit how the initiative is embedded into the OPC Foundation. You can see here that there is an alignment of the FLC initiative, specifically the steering committee, with the existing committees in the OPC Foundation. These are Technical Control Board, Marketing Control Board, and the Board of Directors. At the same time, the steering committee is responsible for all the technical work in the technical working groups that are open to all OPC Foundation members, also responsible for the marketing related activities, and finally, certainly also for getting in place testing laboratories to ensure a high compatibility and the best possible interoperability between devices and controllers for FLC. To talk just a few moments about the technical work, you can see here in the red box all the working groups that are related to FLC. So we have one umbrella working group, the so-called FLC working group architecture, which is making sure that the overall framework fits to all the different groups that are working then on specific details. There is work related to basic concepts, what we call the infrastructure, including information modeling, connectivity, offline engineering. But then we also have specific groups that deal with the semantics, for example, for safety devices, for motion devices. We will start in a few weeks the prototyping working group that is checking and validating all the concepts, and we are also in the process of starting a group to work on test development. You see also here with the dotted lines, we have a lot of links to other groups inside OPC Foundation, and it's clear this is because our solution relies on existing OPC UA technology. The basic formula for FLC is shown here on this slide. So we are combining existing OPC UA technology with underlying IEC, IEEE standards, especially Ethernet, but also Ethernet TSN as the deterministic variant of Ethernet. Very important is the so-called IEC, IEEE 6802, which defines an industrial automation profile for TSN to allow multiple protocols to share one network. And we include also what I mentioned before, the expertise and the knowledge of all the supporting automation vendors. To give you a little bit more insights, at least from an abstract point of view, how the overall system is being designed. As I said, we are relying on OPC UA as we have it today. We are adding basic concepts, for example, a base model, which is the automation component with offline configuration. We are defining communication using underlying pub/sub. On top of that, we are working on the specific models for safety, motion, remote IOs, and so on. And then we are using the concept of quality of service modeling, which is then linking to the underlying transport mechanisms and protocols. And this is where we come now to the IEC, IEEE, and even going down to the physical layer where we find SPE and Ethernet APL. The QoS modeling that we use ensure that we can easily adapt to other upcoming communication technologies, and as mentioned before, examples are 5G or Wi-Fi 6. Finally, you see that we can also integrate device companion specifications, for example, PA-DIM, for example, the companion specs that come out of the VDMA, UMATI. And last but not least, we make sure of conformance testing. Now, talking a little bit about the roadmap of FLC, we are concentrating in a first step on the controller-to-controller use case. This is what we name specification version 1. And then we extend the concepts that we developed for the controller-to-controller use case to also cover, in a second step, controller-to-field device, and this is what we name specification version 2. In the following 2 slides, you find some further information about what is being part of the 2 specification versions. What is important is that version 2 is really setting on top of version 1. That means all the concepts we define now for controller-to-controller are being reused and certainly extended because of some other requirements we have for controller-to-device. And I'm not having the time to go into all the details what is being part of that, so it gives you a rough overview. But I want to already here link to the 1-hour presentations we have on Wednesday, on the second day of the main conference, where you then get further details on the different concepts and parts of the specifications. From the timing, I want to highlight that our plan is to have a release candidate in July, August this year, and then hopefully come to a publication of this release by end of the year. So target is November this year. And I think we can expect, even this is still to be defined, 1 year later, so it will be November 2021, the next version of the specifications, including controller to device. Now, talking a little bit about migration path, especially looking at traditional solutions that you can see here. Typically, we have controllers that use specific field buses to connect to the field devices, and we have OPC UA linking to the industrial network and even public cloud. With our first step in controller to controller with determinism, with different additions like functional safety, we are able to cover the horizontal communication, controller to controller, and especially linking to controllers that use different field bus technologies today. And then in the second step, as you have seen, by adding the controller to field device, we are then extending to have OPC UA brought down to the field level consistently. So we are then able to use OPC UA completely from sensor up to cloud and vice versa, and also horizontally to link machines or machine modules or skids in factory and process automation. To summarize my talk, I want to shortly summarize that FLC contributes to the OPC UA framework in order to add additional facets and profiles and concepts to allow to use OPC UA across all the different layers in a factory and beyond, supporting the use cases controller to controller, controller to device, but also very important, as I mentioned, bringing up the information from the field level to edge and to cloud. And what is also important to mention, this is why I'm highlighting this again, is that we are combining our FLC specifications with underlying Ethernet APL or SPE with TSN, and in future 5G, Wi-Fi 6, so it's future-proof and can be easily adapted to future requirements. With that said, I hope I was mainly in time. You find here my email address, and again, for those interested in more details, join us on Wednesday on the second day for the FLC specific session. Thank you very much.